Hello there, students. Today, we're going to continue our discussion on vectors, specifically their magnitude, unit vectors, and vector components. In the past videos in this playlist on vectors, we've been hearing about magnitude and how vectors have magnitude and direction. I think it's about time that we take a look at what magnitude means and how we can better understand it. If we use a two-dimensional coordinate system, we can draw a vector with the tail at the origin. Here, we see that this particular vector extends 3 units in the x direction and 4 units in the y direction. We can write that out in our bracket notation like this. What happens if you're asked how long the vector itself is in general, shown in red? The size of vector A is what we call its magnitude. There are a few ways magnitudes are written down in textbooks. The most common way will be to surround the vector itself with vertical lines like this. In some linear algebra courses, this magnitude might be called the norm, and could be represented by double vertical lines on each side. Some books or professors will choose to write just the same letter that denotes the vector, but not write the arrow, since a magnitude or length is a scalar and no longer a vector. So the magnitude of a vector A would just be the letter A. For this playlist on vectors and future videos, I'll commit to using the most common shorthand, which is just the capital letter of the vector from which the magnitude is calculated. So, how do we actually calculate a magnitude though? How do we calculate the length of vector A here? You may have noticed that the geometry we've drawn here, when we look at the vector itself, the x component and the y component, is a special type of triangle. This is a right triangle, which means we can use the Pythagorean theorem on this triangle. We know the lengths of the two smaller sides, which are the x and y components, and the hypotenuse or longer side is exactly the length of vector A, which is the magnitude we're trying to find. Here, we see the Pythagorean theorem gives us that the magnitude of vector A is equal to 5. So, written as an equation, the magnitude of a general two-dimensional vector in Cartesian space would be, this is just the square of each component added up, then take the square root of that. We can extend this to 3 dimensions when we include the z component like so. For the second topic in this video, we need to talk about a special type of vector we've seen when we first talked about how to write down vectors, when we saw this notation. Vector A is equal to a sub x I hat plus a sub y j hat, yada yada. These letters with the funny hats are called unit vectors. Let's see what these are exactly. The funny hats are to help differentiate them from generic vectors which have the arrows. This is because unit vectors have a specific property that we've defined them to have. Let's take a look at the definition of a unit vector then. Unit vector A is defined as vector A divided by the magnitude of vector A. The triple bar equal sign means is defined as. Since unit vectors, by definition, are just the original vector scaled by its magnitude, the direction of the unit vector is unchanged. This means A hat points in the same direction as vector A, and this is the whole point and purpose of unit vectors, to specify a direction. We define unit vectors in this way specifically to ensure that they have a magnitude or length of exactly 1 unit, which is where they get the name unit vector from. Let's take a look at our example vector again. If we have a vector A equal to 3 in the x component and 4 in the y component, we can first calculate the magnitude of the vector, finding that it is equal to 5. Then, we can use the definition of a unit vector above to find the unit vector that corresponds with vector A. We divide each component of vector A by the magnitude of vector A, which was 5, giving us this new vector. This is vector A hat. We can look at this on a graph. Here we have vector A in white, and now the unit vector in purple. We see that the unit vector is smaller in magnitude, but still points along the original vector, meaning the direction was preserved. Just to make sure our definition works, where the unit vector should have a magnitude of 1 unit, let's calculate the magnitude of our unit vector A. For this one time, I'm going to use the vertical bars in order to differentiate between the magnitudes of vector A and unit vector A. Just as we should have expected, it's equal to 1. For the last topic in this video, we will cover how to look at vectors and their components. Let's take a look at our vector A, starting on the origin of a Cartesian coordinate system. We see that it makes an angle theta with respect to the positive x-axis, and we can label the x component and y components of vector A like this. If we look at the sine or cosine of this angle theta, which is defined by being equal to the opposite side of a right triangle, divided by the hypotenuse for sine, and the adjacent side of a right triangle divided by the hypotenuse for cosine, we can write down these expressions. Here, we notice that the hypotenuse is none other than the magnitude or length of vector A that we just learned. We can also look at the tangent of this angle theta, which is defined as the opposite side of a right triangle divided by the adjacent side. Taking the inverse tangent of both sides, we can recover an equation for the angle theta itself. These equations might be useful in a problem or situation where we are given a bearing or a heading. For example, if you're told an airplane piloted by Captain Spicy traveled a total distance of 400 kilometers heading 30 degrees north of due east, and you wanted to know how far east it actually is from where it took off, you could figure it out with these equations like this. Here, the component that we want is the x component of vector A, because that is the part that lies along the east axis. If we choose that equation and solve for a sub x, we see that it's equal to the magnitude of vector A times the cosine of theta, which is 30 degrees. Thanks for watching and learning about vectors. If you found this useful or want to see a specific topic covered, post a comment below or head over to my Facebook page in the video description.